think it was ilikuwa very elaborate. I also like made the calculator function and tried it out and it worked. So nilikuwa
Okay.
yeah.
Do you mind showing us your code if you're in a position to?
Yes, I think I can. Acha niangalie kama ndakumbuka mali
Okay.
nilisave.
Okay, sawa.
So just to add on auto nishaongea, when you ukifunza then upatiana like practical real life examples, I feel in a sync better because now somebody can relate easily other than just the more of the theory part kind of.
Yeah, that makes sense.
That's what makes yesterday different.
Okay. Okay. I think that is good feedback. I think we'll try to do the same today as well. So we'll wait a few minutes as Ian sets up. Ian, you'll just tell me when you're ready.
Sawa. Yeah, I found it.
Okay, you can go ahead and share your screen.
Unaona screen yangu?
Yeah, it's visible.
So jana tulifanya hizi vitu zote but sasa hii tuliacha tuko tumemalizia. I don't know which one it was. Yeah.
Okay. Yeah. Laura had asked about it. I hope it's clear from Ian's implementation. Yeah, because it's easier when you actually now implement it yourself, and it also shows that like you completely understood what we were doing with the constructors. Okay, this is nice.
Yeah, so like I can try running this and haijafungua kwa terminal vizuri, sijui.
Are you in there? Oh, you're not in the right folder.
Yeah. So, but if I run it, I can run it here still.
And so you can create multiple instances of calculators, right? You can have another calculator down there.
Yeah, so you can have another one here. Here goes the new calculator. Atumia Copilot, so we have 4 and 5 there. I have to console log it. You can subtract it. We get -1. So yeah.
Okay, this is nice. At least we can see like how you'd implement like multiple instances of a calculator. Yeah, so thanks. That's a very nice. At least you took the initiative to actually do it, which is always a plus. Okay. Okay, so I think we can start. So let me share my screen. Should already have my files open. So we'll start with this. Everyone can see my screen plus my code.
Yeah, sure.
Okay. Let's clear this. Let's just do a refresh. Okay, so our terminal is clean. Okay, that's as far as we can go. Okay, so we've been looking at how to create objects using constructors. So functions, so we have a function that acts as a constructor, and then we use that to create objects. Okay, so that is what we used to use in ES5 before ES6. So ES6 is the version of JS that introduced a lot of new features. And now from that time, JavaScript is now updated every year. Before that, that was not the process of updating JS. I think before ES6, the last time the language was updated, the last ES was in 2009, if I'm not wrong. So you can see there was a huge gap between 2009 and 2015. So it came with a whole suite of new functionality, new syntax, and all that good stuff. So that's why you normally hear it a lot in the conversations. Anytime somebody is talking about JS nowadays, they will always mention ES6, and it's because it came with a whole suite of new functionality, new syntax, just a bunch of stuff. So one of those things was an easier way to, a more conventional way to create classes. If you've ever interacted with any other language, like object-oriented languages like Java, C#, I think is C++, C#, all those, the C suite as well, they are OOP. So you can create classes directly. What we've been doing with JavaScript using functions, it's like a hack. We're just mimicking class behavior, okay? Because JS by default doesn't have that syntax. So even what you're going to be doing today is just what is called syntactic sugar. It's still using the original function and then the name of the constructor behind the scenes internally. But now what it gives us is an easier way to define classes using what looks like conventional code from anybody that is from a background of object-oriented programming. So, so using classes and subclasses to create objects. So just as I mentioned, they were introduced with the release of ES6 in 2015. They are simply syntactic sugar. So basically an easier way to create objects. So this is the syntax. Okay, so you have your class keyword right here. Then you have the name of the class, and then you have the curly braces. So it's like you're declaring an object. You're creating an object. And then within it, you have this constructor function here. So now this constructor function is what is responsible for creating that object. So here is where you pass in your arguments, your first name, your last name, and then now you obviously instantiate them with this dot first name, set that to first name, then this dot last name, you set that to last name. And now, remember when we were declaring our methods, we would put them as properties, right? We would have, for example, this dot say hello would be here, then we would set it to a function. And then now that is what we would use to call that method from the object. But with ES6, with classes now, you define them separately. You don't need to have a function keyword. You don't need to have a this. Just define the function directly, just here. We simply have the say hello function here. Open up the parentheses, the curly braces, and then we return that value. We still have access to this, as you can see. You can still say this dot first name, and then you return that value. So this is the markdown file. So let's now do it in the code. Okay, so creating Matthews. So the first thing is we use the class keyword. Okay, and then we call that class the person class. And then we have our curly braces. And immediately after that, we have our constructor function. It takes in the arguments that we want. So we want the person obviously has a first name. The person obviously has a last name, right? Then we can now set those values within the constructor function. So this dot first name is equals to first name. This dot last name is equals to last name. We get done with the constructor function. The next thing we need to do is, if we have any methods that we want to include with our class, then we do it here. Right? These are methods that are going to be available to the object that we create using the person class. So let's do that. So we want say hello. And then we simply want this to return backticks hello. This dot first name, close this. This dot last name. That. So we are done. We have defined our class. Now we need to instantiate it. So the instantiating part is the same as when you do it using the functions, when you're using your ES5 syntax. So const in show is equals to new phone. Then we pass in the first name, in name. And we console log gen. We have it right here. So the exact same thing happens. So it's just an alternative way to write your objects, to create your objects. But it's a cleaner way to do it. It's a more recent way to actually implement classes. There are some other benefits that we'll get into when we get into stuff like inheritance and prototypes. Is the code making sense? Anybody with a question? Do you guys think this syntax looks easier, or does the other one look more intuitive? Maybe I can put a comparison here.
So Ian, we're just building on what we learned yesterday.
Yes. So
Okay.
this is just basically whatever we had yesterday. But now instead of using the function keyword and then the person, we now use the class person. So we are building on top of what we learned yesterday, on top of some other stuff that we have not covered yet. But we're starting off with classes, then we go into prototypes.
Okay.
Yeah. Okay. The syntax makes sense. So we can then.
I don't know whether it's just me, but this feels a bit more complex for, let's say, smaller projects that someone would be working on, but it would probably work when you're building bigger projects.
Yeah. Yeah.
Would have more objects.
Yeah. Let me also put the other one here just for so that you guys can compare. Let me put the other syntax. So this is how you do it using classes. And this is how you do it using ES5 syntax. And you have your first name, you have your last name, then you have your this first name, this last name. So this is how you do it with ES5, right? And then now if you want to declare any methods, then you have your this dot say hello and set that to function. So this is ES5. This is 5 syntax. This is ES6. So anytime you write your using the ES5 version, VS Code will always ask you whether you want to turn your constructor function into a class. As you can see, even right now, down here, you can see it's already telling me we can convert that constructor function into an ES6 class. If I hover here, you can see the constructor function may be converted to a class declaration that's coming from TypeScript. If I just click on this, it will convert it into a class, as you can see. Make sense? Okay, so now because you have like a comparison, I'll just leave that there. We'll change it. I'll comment it out because I do need to create another class. Same name. Okay. So now we've looked at classes, how we can use them to create objects. We have looked at the ES5 version of how to do that. So now let's get into prototypes and inheritance. Okay, so now let's get into that. So now, before we even go further, whatever we have here, this value here, the person object, if I open it up, I can see I have my first name right here. I can see I have my last name property. And then upper chini right here, I can see I have a prototype property right here that is set to an object. It's an object. If I open it up, you can see we have a constructor, and then we have the function say hello. So this constructor basically means what constructed this person, this object. It was created by the person class. That's why you can see the constructor is the class person. And then within that object, within the prototype object, we have the say hello method, which is this thing here. So every object in JavaScript has a prototype. So think about it this way. Me, as Ian, I have parents. So obviously I've inherited some things from my parents. Okay, some character traits. Kuna vile mi behave kama hao, labda vile nakaa, all those things. These things I inherited from them. And my brothers, also these things they inherited from them. Same thing with objects, right? They have to inherit from another object. So there's two types of objects. There's two types of prototypes. Okay, so currently you can see anytime when you use the new keyword, the constructor, the prototype is set to the constructor, as you can see right here. The constructor is this thing that made the object. And then anytime you use the literal syntax, so if I come down here and I now say, right, and say const Jake, that first name, so if I now come down here and I console log both of them, if I console log Jane, so, and I also console log Jake, so you can see this one, we have this constructor, right? So it's coming from the person constructor. But for the other one where we used object literal notation, we simply have the object. There's nothing pre-appending it. That is because now if I open this up, you can see this prototype right here is just called an object. Haina jina ingine. Because this comes from object dot prototype. So when you use the object literal notation, this one, it will inherit from the default object of prototype. So this is like the single source of truth. Every object that you create, whether you use the new keyword, whether you use classes, whether you use the ES5 version of it, at the end of the day, right, there has to be an ending point. Lazima kuna mwenye alianzisha the whole process. there has to be somewhere where all the objects are inheriting from. And that is the object.prototype, which in itself is an object. So now if I come here, I open this up, right? I can see I have that prototype right here. So my object, this one, right, that is called jackdaw, is inheriting some functionality from the object prototype. And you can see all these things, all these methods, all these properties are available on that object. So for example, let's say I want to check whether this object called jackdaw has a particular property on it. So we know jackdaw has the first name property and the last name property. Okay. Now, if I simply come down here and I console log jackdaw dot has on, okay, we get a true value. So what it's doing, it's checking whether this object that we created has that property in it. But think about this. This method, we did not create this method, did we? We don't have a function here that is creating that method. We don't have a has on property method. We don't have that, do we? We did not declare it. So where is it coming from? It's inheriting it from the object.prototype, the parent. So there's something after that. There's something that it's inheriting from. That's why we can use has on property on it. Is it making sense? Is that something I need to clarify?
Unaweza rudia hiyo part ya has on.
Okay, all right. So let's do that again. So we have jackdaw, which we know is an object. So let me comment this out first. We know that jackdaw is an object. We created it using the object literal notation, right? So we simply have the curly braces. There's one here. There's another here for closing. Then we have the properties. Now we want to check, right, whether our object, our jackdaw object, right, has a particular property on it. So we have two properties, first name and last name. So we can call the has on property method that exists in the object.prototype, so the parent of our object. And if we look here, you can see we have the prototype here, right? So this object, this is where some of this functionality is being inherited from. If I open it up, you can see I have a bunch of things I can inherit from this thing. You can see right here. Easy vitu zote, I can get them from this object prototype. So the parent of my object. By default, right, all objects in JavaScript, all of them, they have prototypes. And the prototype that is set depends on how you created your object. So you can create your object using the object literal notation, or you can use constructor functions. Now, if I come down here, because I know jackdaw, this object is inheriting from the object.prototype, right, the parent object for all objects, I can simply say dot has on property because I know this method exists on the prototype. So it's checking, it goes, checks whether our jackdaw has a property called first name. If I pass in last name, I get true as well. If I pass in is alive, I get false because we don't have a property here that says is alive. If I want this to return true, I simply have is alive and I set that to a truthy value. Or I set it to is alive so that doesn't confuse you when it returns that Boolean. So we see we still get true. So has on property returns a Boolean value. So it returns either a true value or a false value, depending on whether that property exists in that object. So every object that is created in JS has a prototype, all of them. So now the difference between using literal notation and using a constructor, okay, now if I come here to Jendo, my previous example, I can see my person. If I now open this up, I can see my prototype. It's an object. If I check the value, you can see for this one, right, the first prototype, because there's two of them. There's this one here, and then this, our constructor, right, whatever we use to create the object also has a prototype. So there's two levels of prototypes now, right? So the person, the object we created, the Jane Doe has a prototype, and that prototype is the person constructor, what we use to create that object. And then now our class, the actual person is inheriting from the original object prototype. Maybe you've ever heard of something called prototype chain. So they are linked. So because every object needs a prototype, right, we need to inherit from someone. So even when you use the class, the constructor functions, you still need to have a prototype for that function as well. That's why if I now come here, this is the same prototype that we saw initially when we used the object literal notation. So that means, right, if you are also inheriting properties from the object or prototype, we can also use the same methods within Jane Doe, this Jane Doe here. I can just also come here and say dot has and then pass in the value. Let's look for first name. Get a true value. So again, when we declared our class right here, when we declared our class, we did not give it a function called has on property, did we? We didn't define a has on property here like this and then set it to a function. We did not do that. So where did it come from? It was inherited from the object of prototype. So that's what we mean when we say there's a chain. Everyone must inherit from someone. There's always that the last object is always the object of prototype. That might have been a bit confusing, but we'll take our time. Questions? Something I need to clarify again? Anyone with a query in terms of prototypes?
So from what I'm understanding, I'd like some clarification, is that it's like prototypes, they abstract away methods, all the functionalities involved in an object.
Yes, that's a good way of looking at it, because we don't want to populate all the methods and properties on the actual constructor. We don't want to have everything within this particular thing. Plus, some functionality obviously needs to be inherited from somewhere else. So that API that comes with your browser is what gives you all those objects, all those properties.
Maybe, and you can add that a prototype is just a template for creating object instances. So they borrow from that, the main object.
Yeah, they borrow from the main object.
Is that right?
Well, to some sense it is. But what do you mean by main object? So
sorry, I mean
true,
class.
they do borrow.
Yeah.
Yeah, it is true that they borrow from an object, but it's not necessarily like the main object. Because you can say the main object is the window object, right? But it's not borrowing from the window object. It's borrowing from this prototype. So there's an object that lives on every object. So each object or prototype is available on all your objects because they have to inherit from somewhere. You can't just have them be created out of nothing because they need some functionality that is available on all objects. So instead of defining those properties every time you declare a new object, you need to have a parent object that can be passed down to all your objects, and that is the object dot prototype. Let me open the file where I actually have this talk. Okay, now this is where I have like the MD file. Okay, so every object that is created in JS, they have a prototype. That's just by default. That is how the language works. So let me come back to the JS file. Let me just remove everything here. Take out. Then once we are done with the session, as we'll just go through the code. Okay, so that is what they are. A prototype is an object itself. That's why anytime we log in the console, if I come here and I console log, let's say const, let's use literal notation, the normal one, const tick is equal to, we have an object, we have first name for value, tick. And that is sufficient. We don't need to have other properties. Let's console log that value. So now let me open that file. So when you go to the repo, I've divided all the subsections into folders. So I have a folder for classes and subclasses. I have a folder for prototypes and inheritance, so that there's some separation of concern. But we don't have just like one file explaining everything. And also we are separating the code as well. So come here, let's look at the object right there. We can see, right, from what we are logging, we have a Jake object right here. It has a property first name. And then down here, we can see it has a prototype. So anytime you use literal notation, so when you prototype is set to object dot prototype. That's why we've used literal notation. And if I open up the object, I can see I have an object of prototype here, this one. So this is like the main object, like the parent object for all objects. They borrow from this one, all of them, anytime you create an object. So, but if I now use classes, for example, right? I want to create a constructor. Class, it, and say person, same thing we had initially, and have our constructor. So this is TypeScript trying to interfere. We have first name, we have last. This first name, we have this last name. Then we have const Jane is equals to new person Jane. Now log this in the console. See, we have another object. Now let me open this initial one. Let's look at the prototype. So the immediate prototype for our object, when you used literal notation, is the object.prototype. So the parent object for all objects. Okay, when I look at the person, I can see the immediate prototype is the person right here. And then the person's prototype, because it also needs a prototype because of that chain, is the object of prototype. That's why even though our prototype, right, for the person constructor is not the object.prototype, we can still use Jane.has on property, because the person constructor is still inheriting from the object.prototype. So there's that chain. There has to be someone at the bottom of the chain. Like kuna mali inaanzia, we have to start somewhere. That's why even though we used our constructor for Jane is the person, we can still say has own property. Where did I go wrong? Okay, here. We can still use the has on property method. It's not available on the person. It's not here. So it's not in the first prototype, which is the person, but it is in the object or prototype. And the object or prototype is the parent to the person constructor. That's why iko hapo. That's why we can still use has on property, even though we did not define it ourselves in our class as a method. Yeah, this inheritance stuff can get very confusing, especially prototypes, but like, is it making sense? Kama ni kidogo. Is it confusing you guys a lot? We'll do more examples. Okay, you guys are okay. Anything I need to clarify? Okay, so right, so now we've used the class-based syntax. So now let's see whether it works the same when we use the ES5 version. So now let me comment this, Control KC, and then we have the class person. Let's now have function customer, and we can have first name, last name, and this dot name set that to first name, this dot last name set that to last name. So we are simply defining our constructor function. That is all we are doing. And we can simply now instantiate it. So const new customer. Log Mike. Have our object here. We are using the customer constructor. The customer is what is creating that object. We open it up. You can see same thing, right? You can see, right, our immediate prototype. Same way as the classes. So it's the exact same result. Our immediate prototype is the customer itself, right? So when we use this, when we use the new keyword, our prototype is customer dot prototype. When we use notation, our prototype is object of prototype. Because of the chaining, right, we know for a fact that customer, I open customer, the immediate prototype is the customer, and then the customer also has a prototype on it, which is the object of prototype. Any questions? Okay, all right. Okay, so now let's look at more inheritance. More inheritance. Okay, so we'll continue to use classes, and then at some point we'll switch back to ES5 so that I can show you how we can also do inheritance using ES5. So let me also comment this out as well. So we have a class person, right? But let's say we also have a class customer. And then we have our constructor. Right? And then we have first name, last name. The customer also has a membership property. So this dot first name is equals to first name. This dot last name is equals to last name. Then this dot membership equal to membership. Let's create that customer. So const customer 1 equal to new customer. And Paul, first name, name, then the membership set it to premium. Right, now let's come down here. Let's console log customer 1. And see we have our customer. First name Paul, last name Wayne, membership premium. So this is nothing new. We've been doing this all along. But we are repeating ourselves. Now, if you look at the customer constructor, this section, this dot first name and this dot last name, right, those first two properties, right, are exactly the same as this. Exactly the same. So wouldn't it be nice if we could now reuse this constructor, right? This one in customer, because we don't want to redo this again, these two fields. Is there a way that we can now inherit this particular functionality, right? This functionality from the person. So the person is like the parent now, because we want to inherit some functionality from the person, because all people have first name, whether they're customers or not. So there's things we can mimic, these things we can borrow. So for example, that functionality. So let me just go down. Is the ES5 way of doing it? We'll look at that later. So now let's say we don't want to reuse, we don't want to rewrite this thing again here, because we know these two properties also exist in the person constructor. So what you can do, you can pass in super. So what this does, it will simply tell it to now use this other constructor when we want to define those two values. So let me open a new window. Classes and subclasses. Okay, so right here. So again, we know that first name and last name are also properties that we pass in when we use the person constructor. So if we want to borrow this functionality, this particular functionality for setting these values, what we can do, you pass in super. Right? So this tells it we want to use another constructor. And then you pass down the first name and the last name properties. So those properties are not unique. They're also in the person constructor. So any property that is not unique to customer, you pass it down kwa super, the super function. If you've used React, especially the early days of React, this should look familiar. And then now any other property that is not in your person constructor, you now define them the way you normally do. So this dot membership is not in this constructor. So you just pass it normally, this dot membership and this dot phone. Because those two things are not in the other constructor. Make sense? Any questions? I might have questions, or I might need to repeat a few things. Anybody with a question? Give you some time to look at the syntax. Let me copy this. Into our app.js. Before we look at the output, try to see whether you can understand the code. I have not explained this part. So we are extending functionality. We want customer to borrow some functionality from person. Where we have the extends. So class customer, we extend the person class. That's how it's able to know when we pass in super right here, it's able to know that we want to use the constructor from the person, not from any other class. We've told it here, right here, extend the person, use the person constructor, use the person when you want to inherit stuff. So that's why we are using super here, and it's able to tell you're supposed to use this constructor and not any other constructor. Okay, so now if I come down here, say const.
Yeah, can it extend to classes?
Not. I haven't encountered a situation where I've been able to extend to classes. Maybe I don't know, but I have never seen that. Anyone in the call that has seen that before? Have you seen a situation where we are able to extend to classes? But I've never seen it personally. I don't think so, but I'm not sure.
You're not okay. Can you explain what you mean by extending two classes?
She means what I'm getting from it is if we had another class. I think she means, could we now also extend another class here, right? So we have person and student. Laura, is that what you mean?
Yeah,
I haven't seen that.
Yeah, that's what she means.
Like, do you mean like you extend student from person again?
No, she means we extend from
both person and student.
Student, yeah. We extend from student and person to customer. So customer should have properties from both student and person.
I think it's possible.
Is it? How do you do that?
No, okay, I haven't done that, but I think it's possible because assuming in a scenario of an institution, whereby you have one lecturer from one faculty, and the same lecturer is still maybe a dean or maybe a head of department. They can share the same, yeah.
But I don't think syntax-wise, I don't think you can do it directly here. You can find a way to manipulate it to work, but I don't think you can do it this way, because ideally the person should have everything that is not unique to every other class, and everything that is the same should be in one object, which is the person. So anything that is the same to students and customers. So again, we can now come here because we know students also have first names. We can now extend from person again. I don't think you can extend from two classes within like the same line like this. Syntaxes, I don't know. I'll have to do a bit of research and find out. But I do know that you can now just extend.
Hello, Ian.
Mm-hmm.
Okay, I can say I guess it depends on the language.
Mm-hmm.
Because there's somewhere I read about these class extensions.
Yeah.
And there are some languages like Python. Yeah, Python. It
Mhm.
allows extending more than one class.
Yeah.
But then there are some languages like each and every language it's way on of allowing the number of extension in Zafanya. So when you
Yeah.
come to a language like Ruby, yes, there's a way you can like extend. Ruby natumianga something called I think in model something of that kind. In that if you have some like similar classes that you want up near, let's say a class to inherit multiple properties from different classes, you group those classes under one model. Then from that model, now that's where you can inherit it. But for Python, I've seen it in Python, like you can inherit multiple classes at once. Like sasa can like hapo inaweza kuwa class person, comma, then unaweka student that way. But I guess it depends with the language. But I'm not sure about that.
Yeah, I'm also not sure. I'd have to do some research, but I think we can try and see. So let's try.
I've done a research right now, and it's saying that no, in JavaScript, a class cannot extend with multiple classes which is known as multiple inheritance. It's because in JavaScript, objects can only be associated with a single prototype. And extending multiple classes would mean that an object associated with multiple prototypes, which is not possible.
Okay. So
yeah, so basically no.
Okay. Thanks, Pauline. Yeah, so there is your answer. Or you can't extend multiple classes. So now let me.
Yeah. Okay, so we've extended person and we've defined that we are taking up the properties of first name and last name. So I'm wondering if person has multiple properties, like say 100 properties, we'll have to redefine them in the constructor of the customer, like all of them again.
Yes, you'd have to pass them down here. When you use your super method, you have to define them here.
I think.
Yeah, because super what is
basically I've seen in JavaScript you cannot, but in TypeScript you can, unless you use TypeScript mixing. But what you can do instead is maybe you create several classes and then you pass them as parameters, and then you'll be calling them directly. I've seen an article there that explains how you can do that.
Yeah.
So instead you create them as classes, and then you'll be calling them from parameters. Like for instance, you have maybe an animal, and then this animal you want to define how maybe this animal has a head, a tail, this line, this audience. So you create them as classes, and then you'll be calling them directly from the parameters.
So you can basically, for just what I said, you can find a way to manipulate it so that you're able to like get all those extensions, but you can't do it as a one-liner. The language doesn't support it directly this way. You can't like have an array of classes that you extend like the way Python does. I can put a comma here and say so one student. Basically, that's what we were trying to figure out. So that's not allowed in the language. You can find a way to manipulate it so that it works, but the language doesn't support it like out of the box. Okay, so what this super does essentially, it just calls this constructor, because this constructor knows what to do with first name and last name, which is set them to this dot first name is equals to first name, this dot last name set it to last name. So that we are not redefining them down here. So now if we come down here and we now hit that customer, and we know we also need a phone number for this one. Because the customer has extra properties, we also need a membership. Now, if I now go into my console, I have the customer right here. Open it up. You can see we have all those fields. We have first name, last name, membership, and phone number. So we are extending this functionality of creating these properties from person. And then anything else that is not included in the person constructor, we just pass them, we just use the normal syntax to define those properties. And then again, now, someone has a question or a comment?
Okay, maybe to interrupt. I think you can extend more than even 4 classes, not even 1, even 4. If you say class dot, for example, here we can say class customer, extend, then you say object dot assign, then you put it into the bracket, then you align the number of objects that you want. For example, here you can say class customer extend, then you say object dot assign, then you take the first class. Scroll chini nione huko juu.
Object dot assign.
Yeah. Then you put it bracket. Then you say, for example, the first class. The first class ilikuwa hapo nini gani?
Person.
Yeah, person. Unaweka person. So you can add another class there, like student. Yeah, I guess so. Try you see.
Okay, so let's come here.
I think that's the same Ian, where can you just use the extend and then you define the classes. It's the same actually.
Yeah, so again, like the language you can't do it directly unless you now use other methods. Like you have to manipulate it somehow for it to work. So like for this example, we're using object.assign. So let's see whether it works. It's a very nice way of doing it. So let's try and see whether it's actually going to. Okay, so what about super? But let's try and see. Mission number. Okay. So do we also pass it down to super?
Yeah.
Okay. We also need to pass it down to whatever, to this one. Okay. So let's go to where we define that class. We call it, which is down here, an admission number. It's not working. Am I the one who did something wrong? Doesn't look like it's working. You can see we've passed down the admission number, right, all the way down to here, even when you call super. You know what the problem is? Like when you use super will use one class. It's not going to use both classes. I don't think so. Because angalia kama hapa sasa, you see, whatever it's picking up as the prototype is the person. It's not picking the student. Let me see if I switch it out. Student first. Then person. It's going to complain, I'm sure. Already complaining. So it doesn't look like we can do that. So yeah, so I think there's no simple way of doing it. You'll have to manipulate a lot of stuff. Like lazima where you have to play around with the language until it does what you want. But there's no single way of doing it directly. Like the way Python does it as comma separated values.
Okay. Check the example that I've sent you. On your messages, there is an example on my research. I've seen something like that. Try to check on it on the messages. Yeah. Maybe you can do that.
See. I've not seen all these messages.
The last one. But exactly 1825.
Object data sign, parent 1, parent 2, constructor name, age. My name is John. Isn't that what we did? Like exactly what we did. Let me just take it brief. Try it out. Okay, and then parent 1. So parent 1 is an object. So that's the first object. Then parent 2 is the second object. Then pass down constructor and give it name and age. Then super, then name, then this dot age. So does this mean that both parents have the name property? The child equals to new child John 25. Okay, I'm having trouble following this example. So I think we can do this like on our separate time. We can figure it out because I'll also look at it afterwards because I think this is exactly what I did.
Okay, no problem.
Exactly what I did. Yeah, but this is a very good brain teaser.
Okay.
Yeah, I'll just leave it in the chat. So not in the chat, in the GitHub repo. When I push the code, itakuwa tu bado hapo, but I'll put some comments.
Okay. Thank you.
Yeah. Yeah. Thank you for that, Samuel.
Okay.
Yeah. So as you can see, like when you start to get into this mambo ya inheritance and constructors and prototypes, now it starts to get a bit murky. Like you have to do a lot of practice before it can all make sense. You try to do it as slowly as possible. But the point was, if you want to inherit from another class, then you extend the parent class, and then now you pass down whatever properties that original class takes within super. Then you have your first name and your last name. Any question or a comment? Nelson, you are our resident OOP expert since you've done Ruby, an actual OOP language. No, JavaScript is just pretending to be OOP. It's not really, it's just a multi-paradigm language.
Maybe can you repeat the question?
I'm saying, do you have any comments? Are you seeing some similarities between how JS is implementing classes with the traditional OOP languages like Ruby?
Okay, they're just kind of similar because the constructor basically that the initialize method in Ruby. I guess similarly to it in Python. Yeah, so there's not much difference. They're the same concept.
Yeah. And does Python also have an extend keyword? I think it does.
Python, I think so.
I think it does. I think you can also use the extend keyword in Python. I did it a while back, so I can't really remember. But I know like today's...
Like I just said for Ruby, let's say you want a class to inherit from different classes. So you can put those different classes in a single model.
Yeah.
And then you now inherit from that model.
Okay.
I think that is the only difference with Ruby.
Yeah. Okay. So the code for today, I'll push it to GitHub. I don't think we can do much because that was a lot of code, and it can get confusing very fast. So whatever we've done, I'll push it to GitHub. You guys go through the code, go through the notes markdown file, step by step, try to figure out what it's doing. And then now tomorrow, because I don't want to like bombard you guys with too much. Now tomorrow, we'll touch on it very briefly, and then we will start on the project. So we'll build a project from scratch and write the code in OOP style. We'll just use object-oriented programming to build the application. Any comments, questions? Laura? How was prototypes? How was extending classes? On a scale of 1 to 10, how difficult was it? She left. Okay, I guess I'll see you guys tomorrow. If you have any questions, just ask in the group, and then we'll try to like answer those questions. I know today's session was a bit on the more difficult spectrum because of all the things we were trying to do. But if you take your time and you go through it pole, it should start to make sense. Then now when we use OOP tomorrow, you should now see instances where you can use object-oriented to build out your projects. Okay, Davis, how was the session? Are you still here? Ama akili inachemka?
Akili inachemka kidogo, but I will still review the code and all. But yeah. with time, like probably by weekend, it's going to make sense.
Hata mimi, this one took me a while to figure out. I had to redo it a bunch of times before I actually understood what it was actually doing. And all this stuff that you see with OOP, the setter and the getter methods, we can't cover them tomorrow. I think we'll cover them on Friday. To cover them on Friday, because now those ones are even more complex. Like now you're now getting into objects kabisa, because we haven't even looked at how to create objects using object.create, which is another monster on its own. So, okay, but what is this __ proto, the prototype? So it's the same thing that, what time did you join us, Albert? I think it's the same thing I was discussing just now, a few maybe 30, 40 minutes ago.
Maybe I joined a little bit late, so
Yeah.
I found you discussing about prototypes and the fact that a prototype helps us join. It's like a chain. You're creating a chain between objects. Yep.
Yeah.
Was it so? Yeah.
Yeah. I think if I remember correctly, the __ proto should be the same thing. If I
As
remember
prototype.
correctly. Yes. I
Okay.
think it's the same thing. I think it just shows up differently, depending on your browser. So on mine, it doesn't show up as __ proto. It comes as that. It looks like an array, but I think it's the same thing.
Okay.
Yeah.
So.
Yeah. Yeah. Because maybe on yours it's coming as __ proto. Or is that something you see?
And it's something I've been seeing with objects when just going through the documentation, and I find myself going back to objects. I find that proto thing. So,
yeah.
I am having prototypes.
Yeah. Can you see the __ proto anywhere?
Yep, I have the __ proto somewhere. With the last prototype that is linking to the main object. So, like it has. If you open, okay, you're no longer sharing your screen, but no problem.
Yeah, I've seen it.
You've seen it, yeah. If you open those carrots, what are they called? Those drop downs. Further,
Yeah,
you'll see
I've seen it.
photo somewhere. And then I normally see it when going back to the documentation on objects. So that's why I asked.
It looks like it's the same prototype. It's because for mine, let me share my screen, because when we share my screen, that's a good question. I'd even forgotten about __ proto. So from my example, so remember the customer class, right? So we know the first prototype is the person, because the person, we are inheriting some things from the person, right?
Yes.
So that's the first prototype. And then now the prototype to the person is the object or prototype, right?
Yes.
Then when I open up this object, if I go to __ proto, you can see it's the same person constructor. I open it, you can see it's the same thing.
So okay.
Because it's
is
this.
Is it linking us back? It is taking us back a step behind.
Yes, it looks like it is, because this is exactly the same as
the previous
yes,
prototype.
The previous prototype.
Maybe open that prototype, the person, the last one that you have. Yes, open that.
It's already open.
Okay.
It's already open.
The prototype linked. Oh, okay. I think.
Yeah, it's linking back.
It's linking back, right?
Yeah, it's linking back, because you see, so this is the first level. When I just open __ proto, it's person, it's the person object. If I open it, I have the constructor, which is the customer, right?
Yes.
And then when I scroll down again, if I open this, right,
you get the person.
You can see, yes, again, if I open this, like it's just like a chain.
Oh yeah.
Yeah, it looks like it's just linking back.
It's going backwards, the opposite direction.
Yeah.
I think I even remember someone talk about that in some blog or something. Okay, thank you.
Okay, that's a nice question. Okay, I hope today's session was not too difficult. Leo tumefanya, we've done a lot of just theory. So now tomorrow we'll take a step back. Maybe to discuss kidogo sana, and then now we'll build out the project in OOP. So that should be way more fun than what we did today. But like the truth is, before you get to the fun stuff with learning how to code or writing software, you have to go through this part of understanding these basics. And sometimes it feels like they are not connected to building software, but they are. They really are. I think even Albert can attest to it. or Nelson or Pauline, anyone who's done, like, if you've used a framework or if you've been doing programming for a long time, now when you get into the habit of building products on a day-to-day basis, you realize these things that you learned at the beginning, they come in handy. They help you debug a lot.
I can give an example. Most of us are familiar with CSS. So when you first learning CSS, I was just talking to some guys who are just new to CSS, and they found this specificity thing very, very complex. But as you can attest, if you're familiar with the CSS, specificity right now is just coming in as simple as it is. So this is what you're experiencing. Something new later on.
It will make sense.
Yeah.
Yeah. Yeah. Pauline, I don't know whether you have anything to add.
Not really. It was a good session. The question of what Laura, I think it's Laura, asked if multi-inheritance works in JavaScript. That was a good question. Yeah, but it was a good session generally. I loved it actually. Yeah.
Okay. Roy, Ian, any comments before we end? Laura, Wekesa, I think that's Wekesa.
Hey, I have a question. Umesema hiyo ni introduction? I mean theory.
Yeah. This is, we haven't like done anything with this code yet. We haven't built anything with it. And then like, this is just scratching the surface with objects. Like if you start going into advanced concepts for objects, you will just get a headache. There's a book I sent in the chat. I think it's by Kyle Simpson. So he tries to go into objects in depth. Those things can get extremely complicated. So what we're even doing is just very basic. This is not even like scratching the surface. But I don't want us to go that direction because it's supposed to be like just learning basics. Because if we say we are going to go that direction, we'll end up doing objects for 3 weeks. So I'm just trying to lay the foundation. And then now, even when you get to a point where you want to use those more complex, more advanced scenarios, then you have a foundation. Roy?
Yeah, sure, it's okay. Nile nimesikia kana naweza unda ChatGPT sahi.
Yeah, so even the basics are, you can do a lot with the basics. It is impressive, but like most developers, especially JS, you know, JS it's a high level language. So most of the time you don't need to deal with the low level stuff. So that's a good thing, but it's also a bad thing. If you've written code in C++, C#, any of those low level languages, even C# is not low level, maybe C++ and C, you normally have to interact with almost everything kwa hiyo machine yako, mambo ya memory, mambo ya cache, sijui nini. But with high level languages, you don't need to do that. It's a good thing because it gets you to up and running very quickly, as opposed to a low level language whereby before you even create like an app, it takes you a long time. Mambo ya compile, sijui nini, all that stuff. So those nitty-gritties of objects, they can become very complex. So normally unapatanga, you can probably do them when you have a good understanding, a good basic understanding of objects. So Roy, you can definitely build a ChatGPT. We will support you. Ian, you have a comment? What did you think of today's session? Is your brain on fire?
Session was fire. Anyway, imekuwa fiti. Looking forward to tomorrow, at least to apply the stuff. Yeah.
Okay. All right. Laura?
Yeah, me too. I'm looking forward to tomorrow. I'm
Everybody
also
just
looking
wants to
forward to
build.
tomorrow so that we can probably go through it again and implement it as well. And also,
You've dropped off, Laura. Can't hear you. I think Laura has dropped off.
Can you hear me?
Yeah, now we can hear you.
I was saying that I'm also looking forward to tomorrow so that we can go through it again and implement it. Yeah, and I was requesting you for the book to send it again in the chat.
Okay, I'll send it, but I'll give you a disclaimer. That book, you will read it for maybe 3 years. It is a dense book, but like once you get it, you really get it. That is the benefit of that. Well, Kits, I know Kits, you're doing other languages. Do you see any similarities between like classes and, for example, if you've done Python or C? I know you've done C. Kuna vitu zinafanana?
Yeah.
Okay. All right. Yeah, I know for you guys when mnafanya low level languages, it may, especially kama umefanya PHP, yeah, it might look the syntax might not be so scary. Lawrence, how was the session? I'm doing a head count. I see whose brain is on fire, who is okay to continue. Lawrence.
Hi, good evening.
Hi.
Sorry, I joined late and I was not a bit concentrative today. But for the few times I was in, the session was good. And this is the first time I'm attending the session too. Hope I'll catch up and see you tomorrow.
Don't worry, you will catch up. We have everybody is very collaborative, even in the sessions.
That's awesome.
Yeah. Okay, Wakesa. Thank you, Juma. Wakesa, today you've been very quiet. Should I be worried? Are you umepotea?
Ni aje?
Poa.
Niko sawa, naelewa kila kitu, at least zinaingia, but I'm surprised ati huwezi extend more than one class juu hiyo ina vitu mob sana. Yeah, so if we can find a way around it, hata kama si direct, at least tujue hiyo skill.
Yeah, I'm sure we can. So I think now you understand why some developers call JS a Mickey Mouse language, because of sasa vitu kama hizo. Something that you think should be there automatically, it's not there. You have to find a way to hack around it. But again, I think that is why we love JS. Okay, who has not said anything? Sam, is this your first time? You were here yesterday.
It's actually my first time, and I'm really loving it actually. And I expect much tomorrow. Yeah, to apply the theory.
Okay, we will do that tomorrow. We'll now we'll build out something with it.
Okay, thank you.
Okay. Who else? Jeff. You've been very quiet. I'm not sure if I saw him yesterday also.
Something like that.
Jeff, are you with us? Anyway, it's okay. So Kesho, we'll build out the project. Now we can use whatever concepts we've been learning for the past, is it three days? 3 days. And now actually use CSS, use HTML, then build something so that we can see how to like mimic in real life. So once we are done with tomorrow's project, because don't think itakuwa kubwa sana, it's going to be a small project. Now, on top of maybe looking at getters and setters in objects, right? On Friday, we will do design patterns, because this OOP can be used when you have a pattern of design when you're designing applications, because there's a way to write code. So we look at a few design patterns and see what patterns suit object-oriented programming. Okay, I don't know whether you guys have heard of something called an IFI in JS. One of those patterns uses an IFI, an immediately invoked function. And we'll also look at that on Friday. And then next week, We will probably do FP, functional programming. We'll do that and see how they are different from OOP. So now how do you use functions to now write your code? And then now once we are done with those two, I think Sasa, all of us can build that ChatGPT Sasa. But don't quote me on that. Don't say anything. But it should be interesting for the next few weeks. Okay, you guys, thank you for joining again. Enjoy the rest of your evening. And I will see you guys tomorrow. Bye-bye.
Thanks, Ian.
Bye-bye. Bye.
Okay.
Good night.
Good night.
Ian.
Yes, Nelson.
After, can you just remain behind for some few minutes after the others have left?
Okay, no problem.